Hello everyone, my name is Venki Rao and this is my colleague Armand Ruiz. We are from IBM. Thank you for giving us the opportunity to present to you today. We are really excited to be here and to present Geospatial Predictive Analytics with Watson Analytics, SPSS Modeler, and Esri. We have a pretty straightforward agenda today. I will first start the demonstration in Watson Analytics, where I will very easily explore a data set that contains information about the types of crimes committed in different states. I will show you how easy it is to use Watson Analytics and why we have seen such rapid adoption of Watson Analytics among users worldwide. Next, I will take the same data set and build a predictive model using SPSS Modeler, the leading data mining workbench in the market today. Using SPSS Modeler, we are making code-free advanced analytics available to business users everywhere. However, I know we all love code here. So at this point, I will hand things off to my colleague Armand, who will show you how you can visualize the results of our analysis using Esri maps, and also how you can create new applications and extensions on SPSS and Esri's technology. Let's get started. What we have here is the interface of Watson Analytics. If you haven't already signed up, I would strongly encourage you to do so. There is a freemium version that is currently being used by close to 50,000 people worldwide. Please sign up after the session to experience it firsthand. Anyway, here is the home screen of Watson Analytics. You can watch one of our several Get Started videos to learn more. Up top, we have the three sections of Watson Analytics. They are Explore, Predict, and Assemble. There's a lot of user experience design thinking that went into these three features. And that is because when any of us is presented with a data set, the first thing that we want to do is understand what's in it. What is the data like? What does it represent? How can I understand it better? Once I do that, the next natural step is to try to understand why certain things are happening. And this is where Predict comes in. Predict very quickly mines your data set to uncover hidden relationships in your data so you can understand the root cause of what is going on. We will not be covering Predict today, but I have included a link to a video at the end of my slides that goes over this in detail. So please feel free to view it at a convenient time. So we have covered the first two things that we all do, which is explore the data and try to understand what the key drivers are. Finally, being social creatures, we want to share our findings, and that is where Assemble comes in. I will demonstrate how easy it is to create dashboards using Watson Analytics so you can quickly share the findings of your investigation. The first thing that I do when I start Watson Analytics is bring in a data set. My data set is stored in an Excel format, so I attach it just as I would attach it to an email. Now, one thing to point out here is that even this upload process of the data is an intelligent process. It is not merely uploading the file. It is also doing a number of statistical calculations to look at the health of the data and returning a data score. In this case, you can see that the data score of my data set is high. It's given me a score of 97, which indicates high quality. So as a user, any decisions I make on this data set can be more informed since I know whether I'm dealing with a low quality or a high quality data set. Now that my data set has been uploaded, I simply click on it and it brings up the three options: exploration, prediction, and view. Since I want to explore my data first, I click on the exploration button. And this brings me to my next screen, and this screen provides further evidence of the intelligent data upload process. Even before I start to query the data, Watson Analytics gives me a number of starting points that I can use. And because the visualization engine in Watson Analytics is intelligent as well, for different starting points, it gives me different visualization options. For example, a breakdown suggests a tree map, whereas since here it has recognized that there is some geographical data, it suggests that these results can be rendered in a map. Since this looks pretty cool, I click on it and immediately Watson Analytics renders a map for me that shows the breakdown of crime by state based on my data set. For example, I can see that in California there were 4 crimes during the period that I was investigating, whereas in Massachusetts, the state that I'm from, there was only 1 crime. So thankfully I live in a lower crime state. Another exciting capability that Watson Analytics has is its cognitive capability, which lets users ask it a question in English. So let's check that out now. Let's say I want to look at the breakdown of crimes by city. I can simply type that into the search bar, and Watson Analytics returns the correct response to my question. I click on this, and I can now simply choose the right response and further investigate my data. For example, I would like to see the various cities for each crime type. I could very simply add city into my visualization, and this gets updated instantly. While this is nice, I think this information may make more sense in a stacked format. So I can quickly change that to display this information in a stacked format. I could change this further into a percentage stack format, and once again the visualization updates instantly. Since I like this visual, I can pin it so as to access it at a later stage. Let us now move to quickly building a dashboard that I can use to share these results. I start by choosing a template. Just to keep things simple, I'm going to choose the freeform template for now. There are multiple ways in which I can bring data into my template. The first way is to directly access the data and drag it and drop it onto my canvas. For example, I like the map that was generated by crime type by state. So I can choose those variables and add them to my canvas, and the map should render momentarily. And there we have it. Another way to bring a visualization onto my canvas is to use the pinning function. If you recall, I had pinned a visualization earlier, and if I click the pin function here, I can see that that visual exists right here, and I can drag and drop that onto my data set, onto my canvas. And of course, I can leverage the cognitive capabilities of Watson Analytics to simply type in English what I would like to see and have it generate a visual on the screen. So as you can see that there are three different ways in which to build and assemble a dashboard very quickly in Watson Analytics. I'm now going to change track. So far we have explored crime data in a number of different states. Let us now assume that I am the police chief of Dallas, Texas, and I want to figure out how to best deploy my police force across the city. To do this, I will build a predictive model that can predict the type of crime that will be committed based on various locations in the city. To do this, I exit Watson Analytics and get into SPSS Modeler, IBM's market-leading data mining workbench. So here is SPSS Modeler. We just released version 17 last week, and I'm excited to share with you that we have a number of new geospatial features that are included in the product and have been developed in conjunction with Esri. Let us take a quick tour of SPSS Modeler. Up top you have a number of icons and file menus similar to any other Windows-based application. The white screen in the middle is where you would build your predictive model in a very visual workflow. At the bottom of the screen, you have a number of tabs that contain different options to drive the model building process. For example, in the Sources tab, we've got a number of different data sources that you could bring into SPSS Modeler, and this is pretty much an unlimited number of data sources. We also have a number of ETL options in the Record Ops and the Field Ops tab, as well as a number of graphical options in the Graphs tab. On the Modeling tab, we've got an extremely long list of data mining algorithms that ship out of the box with SPSS Modeler. If there is a particular algorithm that you would like to use that is not inside of SPSS Modeler, but is included in an R package, you can bring that into Modeler and run it through Modeler as well. And just like there are different sources, you can, once you've completed your analysis, you can also export the data into a number of different sources. So with that quick introduction, let's get started and build our predictive model for the Dallas police chief to identify where in the city what types of crimes are likely to be committed so that I can figure out the best possible way to deploy my police force. We start with a data file that contains information about census tracts. The file format is .shp, which is a shapefile, and it contains geospatial data. In order to bring this file in, we have a new geospatial node in SPSS Modeler version 17. I double-click this node and bring in my data set, which is my shapefile here. We attach a table node to this node and view the contents of the file. As you can see, this file contains information about various tracks, centroids, as well as multi-polygons. Next, we bring in an SPSS statistics file that contains information about crimes committed. We can click the preview button here to preview the information in this file. And as you can see, this file contains three fields: longitude, latitude, as well as the type of crime committed. In order to convert the independent longitude and latitude fields into a point location, we bring in the derive node. We change the name of the derive field to point, and we choose the new Geospatial data field that is included in SPSS Modeler 17 to create a latitude and longitude field. Next, we add a filter node to remove the X and Y fields while retaining the newly created point field, and attach a type node to read in all the values. Next, we use a merge node to merge the two datasets and bring in a type node to identify the target variable. We are now ready to build our model. In order to do that, we go to the Modeling tab and bring in the Association Rules node, which is a new algorithm in SPSS Modeler 17 that can accept geospatial data to identify relationships among the different elements. We then run this model and quickly generate our golden nugget, which contains the results of our modeling exercise. We can now double-click this golden nugget to explore the results. And as you scroll through the results and down to the rules table, we can see that the model is making predictions on the type of crime one would expect to see based on the geolocation, along with the confidence and rule support percentages. Finally, we attach a table node to the golden nugget and if we scroll to the right, we can see the predicted crime based on the geolocation in a tabular format that can then be used to deploy the appropriate police force at the appropriate locations. As you can imagine, as the police chief of Dallas, this is some terrific actionable insight for me. And while I am happy with these results, I wish there was an easy way for me to communicate these results to the rest of the police force. And then I remember hiring this whiz kid for my department who was doing all sorts of interesting visualizations using Esri maps. So I call him into my office and say, Armand, how can you visualize my predictive analysis so I can effectively share this with the rest of the police force?
Thank you, Becky. In this second part of the presentation, what I'm going to demonstrate is how to improve the results integrating this geospatial analysis using Esri solutions. We integrated Esri Esri using predictive extensions. Remember, you can create your own predictive extensions going into Tools, Custom Dialog Builder. From here you can create the user interface of your extension. You can select the properties, change the name. You just have to drag and drop the different elements you want, like field chooser, checkbox, combo box, list box, whatever. And then you go to Edit Script Template, and here is where you actually place your script based on R. So, based on this technology, we created different extensions for some features that are not coming out of the box with SPSS Modeler, like Facebook connectors, Twitter, Foursquare, or new database data sources like Cloud and MongoDB, if you want to open a JSON file, or also new algorithms like the popular random forest, which is an algorithm that is not included with SPSS. Also, based on that, we are providing new extensions for Geospatial analytics, and most of these extensions are powered by Esri. So this is exactly what I'm going to demonstrate right now. We have here the use case of Benki, where we have a data set where you can see you have the latitude, you have the longitude, and you have the crime type. Okay, let's say we want extra information about this place. We want something more extra than only latitude and longitude. Well, for that we have the reverse geocoding extensions. That if I connect here, what it's going to do is connect to the Esri APIs, and basically is going to give me some information about this specific location. So I have two fields to choose, latitude and longitude. I just fill it, I put my username of my ArcGIS Online of Esri, and I put my password. There are two different modes to use this API. The first one is for free, so you don't have to pay anything, but you have a limit of, I think it's 5,000 requests per day. And also if you have like, I don't know, 2,000 records in your table, it's going to do 2,000 requests. If you use the paying API, it's going to send the whole CSV to the ArcGIS, and in only one request it's going to give you the answer. So in terms of performance, it's much faster. Also, you won't have any limitation on the number of queries you can do per day. So I'm going to connect a table here, and if I run this extension, what I'm going to get is a table exactly like that, where I have the same fields I had before, like longitude, latitude, and the type of crime, but at the same time I'm going to get different information like the address of these coordinates, exactly the city. I can get the zip code, which is quite useful, or the full address. In the same case, imagine that I want to use a new data set, and in this case, in this new data set, what I have is crime for another city, the city of Chicago. In this case, I have a very complete data set where I have the type of crime, the gender, even the URL to the crime. But the location data that I have, it's only the address. So I don't have the latitude and the longitude. So I cannot use any geospatial algorithm because I need latitude and longitude. So for that, in the same way, I have here a geocoding extension, again based on Esri services, and it's going to work exactly the same way. I select the address field, which in this case is, here it is, first one, address. I put my username and the password. Again, for this use case, there are again the two different modes. The freemium mode for free with a limitation on the number of queries per day, and it's going to do a request per record, or you have the paying mode, which is going to do only one request, one post request, and it's going to, and doesn't have any limit in the number of queries you can do per day. So if we see the output of this node, what it's going to give me is exactly the same data set, but at the end we have two new fields with the latitude and the longitude. So using that, we can start plotting in maps. We created also extensions to plot beautiful heat maps within the workbench of SPSS Modeler. Here we have our output node web heat map. If I drag and drop it into my canvas and I connect it into a data source where I have some geospatial data, when I double click I can see I have some options to choose here, like where is my field of latitude, where is my field of longitude. I have also to specify the latitude and longitude and the zoom to center the map. And then the most interesting part is that we are providing different base maps. Like we are providing a couple of templates, most of them coming from Esri, some others coming from open source like OpenStreetMap. And this is going to change the whole map experience. So if I run this map, for instance, with the default properties, I get very fast a very nice heat map of the crime in the area of Dallas. So you see now I have a dark base map. If I change this base map into something like imagery, wall imagery, it's going to have now a satellite map. And you can see also performance is very good. So here we have now my heat map data with a satellite map coming from Esri. Another option I have is using, if I have my own, maybe I don't want to use any of these templates, but maybe I want to use my own URL with my own server, because this is something it can happen. So I can do that as well. I have only to put the URL in the proper format and use my own server. So in this case, what I'm doing is using a completely different base map, also based on satellite. And last but not least, I can use third party to create these maps. So let's say I want to use Mapbox, and they have some nice and funny base maps, like the following one, which is like comic style. So these maps are beautiful and are ready to share with anyone. And you can see here is using this funny comic style with the nice font here. Okay, so this is how we are creating maps, and we are using mostly Esri, and we are providing this node with Esri templates. We will be creating new maps to create new geospatial visualizations within SPSS Modeler. If what I really want is to create very powerful geospatial visualization, I should use a GIS system. So for that, I'm going to use Esri ArcGIS Online. For that, to push all the data from my SPSS analysis into ArcGIS Online, we have a new node called Publish to Esri. So let's use it. I connect my Publish to Esri to the output of my prediction. So remember, my prediction, what is giving me is some geospatial information and also prediction of which kind of crime in which location, specific location in the city is more likely to happen. Okay, so I push all this data into Esri. Using this node, I have to specify in which field I have my latitude, in which field I have my longitude. Again, I have to put my ArcGIS username and ArcGIS password. I put the item name, which is going to be the name of my feature map in ArcGIS Online. I'm going to call it SPSS Demo Esri, and I have a tag in order to classify my items in ArcGIS Online. So when I run this, basically all the data is being pushed into ArcGIS Online. So if I go into ArcGIS Online and I log in and I go to my content and I refresh, I can see here it uploaded a CSV file with all my data, and if I refresh again, I see that at the same time it's creating, this is the most interesting part, it's creating a feature layer of my map. So I can see that the feature layer is being created. It's not created yet, because if I go back into SPSS, I see that the process is still running. So this process, it might take, depending on the size of your dataset, it can take maybe 1 or 2 minutes. when the process is over, I can see an output telling me how the publish of the service went, and I can see like the service is being processing for some time, but at the end it's completed, and it's telling me the number of records pushed into ArcGIS Online. So if I come back into ArcGIS Online, I see the process of publishing my feature map, it's over, and I can see already the points here. So if I click open, I come into like the GIS web-based workbench of Esri, and based on my data, Esri is going to propose me different kinds of visualizations. So let's use a feature of Esri called Smart Mapping. So depending on the attribute here I'm selecting from my data, I can see I have the same attributes I had in SPSS: latitude, longitude, the point, and the prediction. Based on that, it's going to propose me different kinds of visualizations. So for instance, if I select here prediction, you can see it's proposing me a new visualization based on the types of the crime. So you can see crimes in violet are violent. If I click in the point, you can perfectly see that is the type of crime. So I like this layer. I click done, and it's over. I can just change the name. I can put that type of crime. What I would like to have as well is another layer with a heat map, because I like heat maps. So let's select again my data set I just pushed. This is it. And what I'm gonna do here now is again use change style, and I'm gonna select the heat map. So it's so easy to create a heat map. It's amazing how fast and easy it is. I can select the area of influence of each of the points. So if I want to put them like more strong intensity, I can do like this. If I want to do it smaller, the influence, I can do it like this. I like when it's a bit stronger, actually. So when I'm happy with my heat map, I click OK, I click done. I'm going to change the name. I'm going to call this new layer heat map. And that's it. It's that easy to create a map with multiple layers. Here I have my heat map, here I have my crimes by type. And something interesting as well is the option of perform analysis. So in ArcGIS Online, I have different options to create an analysis, which is basically it's going to analyze the data, and depending on the location of the data, it's going to find like the density. I especially like this one, which is find hotspots. So if I run this, actually ArcGIS in the cloud is doing an analysis during like maybe 30 seconds, 1 minute, and it's going to find which are the crime hotspots based on the location in the city of Dallas. So this is very powerful because with SPSS we are predicting which type of crime in a specific location is more likely to happen, and using some of the Geospatial analytics in ArcGIS Online is going to tell me also not only the type from SPSS but also especially the place. So let's wait a little bit. It's creating the new layer. This process can take some time because taking into account here is analyzing 7,000 points, which is quite big. It's quite a big number of points. So when this is over, I can see the results of my hotspots by type of crime. Okay, and this is giving me like the confidence. This is like a hotspot with 99% of confidence. If I go here, it's not a hotspot at all. If I click in the blue one, it's a hotspot with another 99%. There are different types of sharing options. I have to save my map first. I save the map like crime in Dallas. I select the tag. I'm going to call it SPSS. So once my map is saved, I can share my map with everyone if I want, with a particular person, or maybe with a specific organization. Let's select everyone. And then I have different options. I can directly publish my map into Facebook or Twitter. I can embed it into my website. It's going to provide me automatically an iframe. But in my opinion, the most interesting thing is the options of making a web application. Esri is providing different templates to create web applications very easily. So you don't really need to be a web developer to create a GIS application. My favorite tool is called this one, Web Application Builder. With the Web Application Builder, the only thing I have to do is drag and drop some elements, create my menus, and that's it. My geospatial data is ready to be shared with everybody in a very user-friendly way. So, for instance, here I selected the IBM, I created an IBM logo, I put the title of my map, a small description. Here I can have my layers that I created before. So I can select the heat map, I can select the crime points. So you can see here in red I have the violent points, and minor depth is in green, for instance. And I have also another layer with the prediction actually. So here I have the prediction. I put some funny icons, and you have the skeleton when the crime predicted is violent. You have a car when you have some chances to have your car stolen. Okay. To change the base map is so easy as well. Here, if I want a dark map because it's going to improve for my visualization, I can select the dark canvas. I can select a clear one, National Geographic, OpenStreetMaps, whatever. And obviously, if you zoom in, the level of detail is great. Some other interesting options here is the charting. So these are all plugins you can add into your application very easily. Again, you don't have to develop anything, you have only to drag and drop. So I can select a define area. I select a define area, and it's going to tell me which are the types of crimes predicted for this defined area. So, and if I select in this case in the pie chart, it's going to highlight these points in the map. So you see, it's a very powerful way to do prediction within SPSS, pushing the data to ArcGIS Online, do some analysis again with ArcGIS Online, do very powerful geospatial visualization, and then creating an application that is user-friendly and you can share with everyone. Based on the same technology, I created another use case to demonstrate how you can integrate SPSS Modeler, some text analytics based on Twitter data, and also Geospatial. In this case, I have a stream tweets node that is collecting tweets of a specific area. You can see here I have a coordinates box. So what I've done is I've been collecting tweets in the area of Palm Springs, which is the area where the Esri developer summit was taking place, and at the same time it was a very important tennis tournament taking place in Indian Wells, which is like very close area. So it was capturing all the tweets from this area, and using SPSS Modeler, what I did was some basic text extraction. I didn't do text analytics. You can do very powerful text analytics within SPSS, but in this case I was doing very basic text extraction. So I was selecting all the tweets talking about Esri, Dev Summit again, GIS. So the basic hashtags or words that people were using to tweet about Esri. And at the same time I was tweeting also, extracting also the tweets talking about Indian Wells, BNP Paribas, which is the sponsor of the event, Indian Wells, tennis, BNP, etc. So I created 3 different categories of tweets, one called Esri, one called tennis, and another one, the third one was for tweets talking about any other topic. So in the same way, since all the tweets have geospatial coordinates, I'm pushing the data into Esri, and using the same technology, I created another funny application using the Web Application Builder in Esri. So in my new application, I have different layers. First is the heat map. So I can see there are basically in the area there are 2 hotspots, one here in Palm Springs and another one here in Indian Wells. So if I zoom in, this first hotspot, I can see, and I select tweets by category. I see my tweets in blue are tweets talking about Esri, in green are tweets talking about tennis. So there are many tweets here talking about Esri, and basically this is because here is the Palm Springs Convention Center. So everybody that was in the conference was basically tweeting. And if you click in one of the points, you get exactly the tweet. So if we go to the other hotspot in the area, which is in Indian Wells, and we zoom in, guess what is there? So we select satellite, and we see that basically there what we have is what is called the Indian Wells Tennis Garden. And if we change the layer, we can see that we have green tweets, and green tweets means tweets talking about tennis. So we don't have many tweets yet, because basically the same week as the conference they are only playing the qualifications, so the tournament didn't officially started yet. So you have some people already tweeting about the tournament, but I'm sure in the week after will be like a lot of people there talking about it. I use the same algorithm to do the hotspots, to select the hotspots, and I can see as well that the Esri algorithm is finding hotspots exactly in the same areas as we have the two big events, one for the Esri conference, around the Esri conference and around the convention center, and also around the Indian Wells Tennis Garden. So again, this is a very nice use case of Twitter data, text analytics. I can do some prediction as well if I want, using SPSS, pushing the data into ArcGIS from Esri and creating this map application. Okay. I guess you wonder how can you get these extensions. You can go to analyticszone.com, and here you have like a marketplace where you have some of these extensions. We are updating this site regularly, and here you can see the get coordinate, the reverse geocoding, and some orders for maps. So you can just click here, you will have a description, you have screenshots, you have even a video tutorial on YouTube, and also you have an install guide here with the PDF, with all the instructions, how to, you have the license, how to install the extension, and also how to use it. And to download it is as simple as just click here, download, and that's pretty much it. Okay, thank you very much, hope you liked it.